meet Siemens Industrial Copilot. The purpose of the Industrial Copilot is to help or augment the users by bringing human-machine collaboration to the next level. Currently, the Industrial Copilot is employed in two use cases: Industrial Copilot for engineering and Industrial Copilot for operations. Industrial Copilot for operation aids maintenance engineer or operators. They can ask the questions to a machine and machine can respond in a human-like manner. Take Schaeffler, a leading automotive supplier and one of the automotive industry to embrace generative AI both in manufacturing and also in the operations. Can I have a live demo, please? The machine which I showcased in the screen, this is co-created by Schaeffler and Siemens. The digital twin of the machine we have showcased in SPS 2023. Interesting fact is, this machine entire automation code is created by Industrial Engineering Copilot, and it is integrated with Industrial Operation Copilot. And the interesting fact is, the maintenance engineer or operator can chat with this machine and machine responds in a human-like manner. Like, I can ask this machine, how many good and bad parts produced so far. Operation Copilot has access to all relevant manuals of the machine. In addition to this, it has access to live data of the machine also. So here you can see the Operation Copilot analyzes what is the live data from the machine, and it gives me that good quality products has been produced so far 214, and it is also gave me a statistics of 42 bad parts is produced. Not only this, Operation Copilot is good at prediction also. So right now we have seen with the current statistics, I can ask the Operation Copilot how many parts it can produce for the next 1 hour. Operation Copilot, with the current production rate, it will estimate what is the future production it can be produced from this current machine. It is right now calculating. As you can see, I can able to expect a 560 quantity in the next 1 hour with the current production rate of 6.42. Isn't this cool? Right? Operation Copilot is not only good at the statistics, it is very good at pinpointing the error in the machine. Like, maintenance engineer asks a machine what is the problem, and it will give exactly what is the problem in the machine. Not only the problem, it will give steps to resolve the problem itself. I can bring back this machine to an error state, like by reducing the air pressure in the machine. I will start the machine and I will reduce the air pressure. So soon after I reduce the air pressure in the machine came to error state. Okay, but operator doesn't know what is the exact error in the machine, right? I can ask the Copilot, machine is not performing well. What is the active error? So as I mentioned earlier, the operator doesn't know what is the error in the machine because error can be a different form. But Operation Copilot aids the maintenance engineer or operator by pinpointing the exact error and also steps to resolve it. Right now, you can see we have brought the machine to error state, and exactly Copilot operation found out there is a problem in air compressor, and it is suggesting air compressor in off state. So I can increase the air pressure, or operator can increase the air pressure back to normal, and with that the machine will come to a normal condition. I can ask back what is the current status of the machine. The machine, sorry for the typo. So this Operation Copilot, again, check what is the current state of the machine, and it will tells me the current status of the machine is in automatic mode, right? This is the beginning of new era. In the past, we have to talk to the machine in their own language, but we can talk to the machine in our language right now.
The complexity, the sheer complexity of the data centers are just pushing us to have AI-based data centers or autonomous data centers, so the actions are taken as and when there is a threat. For example, if there is a cyber security threat, the AI itself should take control and do some actions before the humans can even think of. So AI and autonomous data centers are a trend now. If you see the market potential of the global data centers, 302 billion, in the next 1 decade, it is going to be doubled up. This industry is not going anywhere. It is going to go and grow exponentially. What we have in APAC, 75 billion in 2026 itself. 75 billion is a huge number, and India contributes a lot onto this business of 75 billion. We are one of the major investors in data center, major players in data center, and 75 billion is the APAC growth. And most of it is coming from the AI data centers, which is a trend which is happening presently. Energy efficiency is a big topic for data centers to survive and for us to have the sustainable future. So 1.1 billion to 4.5 billion is going to be the total investments going to be in the data center energy efficiency topic. Sustainability, green data centers is a talk of the day. Renewable energy has to be there for the data centers. So that is a huge, huge market. 147 billion is the investments expected into this. Now, how a future data center will look like. Previously, if you see here, a data center is predominantly an energy consumer. It consumes a lot of energy. We had the cloud-based technologies. It was basically serving the cloud. The data center was mainly cooled by the air cooling systems. But trend is changing. A future data center will look totally different. It needs a lot of energy. So it has to produce a lot of energy in itself, in the area where it is operating, or it has to move to a place where the energy producer is able to give a power at a cheaper price. So now the data center, being a consumer, they are going to be a producer as well as a consumer. When the data center is in full swing, they consume the energy, and when there is no much operations, they are at a free will to give the power to the grid. So it is a producer as well as a consumer of energy. The cooling changes. Cooling in data center is very critical. The power capacity is going very high. So what we need to do is that instead of air cooling, it will go to liquid cooling. A lot of services which were predictive analytics on cloud will now change onto AI-based services for operations. Lot of regulations will come in terms of sustainability, in terms of carbon emissions. So previously it was not there. Now the future data center has to face a lot of regulations and sustainability issues. The grid participant, it is going to be a participant or to be a member to provide data energy into the grid. So the future data center is totally different. The CPUs are going off, GPUs are coming up. One GPU in the terms of 120 kilowatt, that is what NVIDIA and all is talking about right now. Application-specific integrated circuits, ASIC is coming into the picture. So the compute is going to change the future. The power requirement is huge. A simple ChatGPT search on an internet takes 10 times the power than a Google search. So you can imagine multiple people logging on, getting for a ChatGPT search, how much of energy is being used there. So power is going to be a very big criteria here. Cooling. As I have told, normal cooling will not suffice. To a certain extent, yes, it may, but after a particular limit, only direct chip to cooling. So the chip has to, the cooling has to be facilitated onto the chip. So that is a new trend.
The overarching idea is to combine the real and the digital world together. But while we do that, the three pillars that we want to keep in mind is decarbonization and energy efficiency. All of the building infra that we build in today, we want to make sure that they are decarbonized or as sustainable as possible. And more on this is in the Transform booth at Transform Infrastructure. I urge you guys to have a look at what our colleagues are doing, some incredible stuff there. The other pillar is resource efficiency. I think we have a ton of assets in our building, and the people who run this building are our valuable resources. And how can we improve their productivity? How can we maximize asset utilization is the second pillar. And the third is people centricity, the social impact of it. The air we breathe, the safety we feel around here, the lighting that serves our productive environment, that's people centricity. And all these three topics are part of Transform Infrastructure booth right next hall. If you haven't seen it yet, I urge you all to go and check it out because some amazing work is going on here. And at this point, I'm super proud to say that 90% of Siemens' business enables customer to achieve a positive sustainable impact thanks to these three pillars that we have: people centricity, resource efficiency, and decarbonization. So in a nutshell, all the tech, the smart infra tech, the safety, the fire, the BMS, the security that we've been doing for years now has been generating a ton of data, which we have been able to convert not only to build safe environments for ourselves, but also to build sustainable and more productive buildings for the future around this area. And the digital and the real part actually makes this happen. The building digital twin, which is something that Francis also covered. And I have an example of a digital twin here from a data center. And honestly, this is one of my favorite applications from Building X. Because when I talk to customers, one of the biggest challenges they have is how to manage asset more systematically. So for example, if you were the facility head of this room has a ton of asset. Even the lights, the speakers, the diffusers, the smoke detectors, each of this is an asset. And if I were to ask you to fetch me data of that smoke detector, it will be a Herculean task to go to the basement, find out what make is it, when was it installed, whether it is in warranty or not, what was the commissioning certificate looking like, is it as per design. There are so many stories, or there's so much content that one smoke detector has to share, but the data is all over the place. With the life cycle twin, we are able to address exactly that challenge for facility engineers. So for example, this is an actual digital twin of one of our data centers. And the moment I click X-ray view, I get to see it in X-ray. And I can see here, there are these 4 or 5 racks which are buzzing alarm. So let's go check them out and see what's happening. And here there is an alarm clearly. And I want to learn more about this asset. Now imagine in a real world, this would be very difficult to do. But in the digital twin, all you need to do is click this asset here and turn on the component sheet over here. There you go. Here, for this particular asset, we can learn a lot about this particular rack. So what's its object ID, what's its name, description, serial number, barcode, its warranty information, its installation, when was it installed, by whom was it installed, who was the vendor, whether it is in annual maintenance contract, and so on and so forth. I can also see some attributes pertaining to this particular asset, and I can see documentation as well. So for example, if I am a new facility engineer and I've been asked to tackle a live problem with this particular asset, I have no idea what it is. So all I need to do is go to this particular asset in my digital twin. I can even carry an iPad, scan a QR code, and this same screen can open. And I can see here all the documentation pertaining to this asset systematically placed in order right here. I can download them, I can interact with them, I can share them. And let's say if I'm unable to address it, then I can go to tasks here and I can raise a work order. Before I do that, I can also see all the previous work orders that were related to this particular asset and their status. So here I can even notice a trend if a same error is occurring again and again, so I may have to use a different approach. And finally, I can just go here and create a work order here in tasks. And I can see here the work order automatically tags the asset information and the documentation in my ticket. So I can say demo order, and I can even assign it to a colleague who I think is an expert here. So I can assign it to whoever my colleague is. So this is all integrated with my Active Directory. So I have assigned it to Frederick here, and I can even give them a due date. I can describe the problem and I go ahead and save. The moment I save it, Frederick in his iPad or on his digital twin platform gets a notification, and a chat between the two of us is also open, where I can talk to them about more in detail of what this challenge is, or he can ask me questions. And of course, he has all the asset information, the documentation, the complete metadata of this particular asset readily in hand, in the palm of his hands. It's an absolute breakthrough in terms of what Building X can do. We started by comparing buildings, by comparing locations, by comparing energy. We went into fire analytics, we went into security analytics, then we went down to the asset level, and in the asset level we went down to the document that was uploaded maybe 5 years ago when that asset was commissioned. And I think this essentially transforms the way we interact with infrastructure as compared to what we do today. This essentially enables us to unlock the potential of data to its highest limit. And the IT and the OT correlation that I showed you, the more we interact and the more we use this data, I think the more intelligent the platforms will get. And that's where we will be able to welcome artificial intelligence more strongly in our future with infrastructure.
The Siemens plant, the Siemens factory at Amberg, Germany, which is the lead factory for this type of products that we have here. And it's also the first factory for which we have developed a decarbonization roadmap. The decarbonization roadmap you see here on this graph with the columns going from the baseline in the year 2020 to the year 2030, which is our target date by which all Siemens operation has to be carbon neutral. What we did there was that first we found some efficiency gains, both in the building infrastructure and also in the operations, but not a lot, because the colleagues before, also just for cost-saving purposes, had done quite a good job. And that's a pattern we usually find. Then the large improvement comes from combining rooftop PV with then an electrification of the heating. And then also the next step, and that's also with increasing investment costs, yeah, that's the logic of the order. The next step is then to get the cooling more effective. What we are using there is an absorption compression chiller, which allows to convert waste heat into useful cooling. And then the next one was to replace the fossil gas needed for the process to produce 1000 degrees centigrade by biogas. This is possible because there are some farms in the vicinity with which we are able to conclude decade-long contracts, thus also insulating the factory from fluctuating oil and gas prices. And then there is a small tail, you can barely see it, that is just not reasonable to avoid, and that will then be compensated by certificates. Is this a footprint for the world? No, because there is no one size fits all for every site. Already the climatic conditions are different, the environment is different, the type of the process you have is different, but what actually works is the method we use to figure out what is the tailored, ideal solution for this site. And we have been applying this also not only to many sites of the Siemens AG, but also to customer sites. Here you see one example from an automobile manufacturer, which reflects the cost related to this. You might say this is nice, but looks expensive. So at the top, you see the original design that the automobile manufacturer themselves had done for the factory, which is actually a greenfield factory for electric vehicles. And there you see, compared to that, in the second line, what their design would have been for a carbon neutral factory. And they would have expected actually the cost to be about 20% higher compared to the original design, which would have emitted 500,000 tons of CO2 every year. And underneath, you see 3 scenarios that have then been evaluated with our standardized approach, and they are all about 25% less cost intensive than their design. And the reason why this is possible is that you see in green the CapEx, in gray the OpEx. So one pattern you have when you want to decarbonize, you need to invest now, but then you have lower energy costs afterwards. Logic, because you have to purchase less fossil fuel. And this is how we do it. We generate a digital twin of the brownfield situation as is, modeling the energy system we find there, and not only of the site, but also of the surroundings, because a lot of the low-hanging fruits actually come from the intelligent interaction with the surroundings. And then we complement this as-is digital twin with a full enumeration of potential other technologies, innovative technologies that could possibly be installed in the site. Those you see here in yellow. And then we give it to a mathematical optimization algorithm and let it figure out the most cost-effective way to achieve the decarbonization targets, and to figure also out which are the safe bets and which investments you might want to postpone because they're very much dependent on future evolutions of interest rates or prices. And we have been applying this process to quite a few industrial verticals already. You have seen the example from the automobile industry. We have been applying it to food and beverage plants, to pulp and paper, to manufacturing, and also to data centers. You might have, some of you might have been in the session just before here in the other room. What I want to stress here is that what has been presented in the session before was what can happen inside the data center, what you can do to help get the data center itself more efficient. What I want to draw your attention to here is that by getting the data center to interact intelligently with the surroundings, with the environment, you can use the waste heat with an adsorption chiller, as mentioned before, to generate useful cooling, for instance, for a district cooling system. You can use an organic Rankine cycle to generate, then to use the waste heat to convert it into electricity again, and you can interact smartly with the grid to compensate also fluctuating renewables.
So to showcase some of the examples in this regard, I am bringing here the 2 such specific examples. One is the green simulation. We have seen how SimCenter 3D can come into picture and help to take the informed decisions. So we have developed an in-house utility. While we run such simulations, we could measure how much emissions are happening because of such simulation activities, and then optimize further to take the informed decisions. So some of the influencing parameters could be the location of hardware itself. The geographical location will have different source of energy. Based on that, the carbon intensity coefficient will vary, and thus the sustainability index. And then, so some of the outcomes which looks like this, for example, if such a trade-off, it will tell us that to improve the accuracy of the simulation by 3%, probably it will demand us the double carbon emission. So such insights will help users to take whether they would need to run multiple of such computations, whereas they would need to increase the accuracy by 1 or 2%, whereas there is a lot of demand on the energy. So similar implementations were also done for the green machine learning, where we have this in-house utility which will help to know the emission numbers and then further optimize the parameters, run the sensitivity analysis and come up with the final control parameters which will help us to take the good inputs for the better one in terms of the energy consumption to make the technologies green. So we were demonstrated that on some of the probabilistic neural network in-house, and then we were able to see near 50% reduction of energy by controlling the parameters, and then it also gives a nice trade-off based on where we have to operate. So what we see here is a good interlinking between the technologies and the sustainability, and how can we bring in the sustainability thought process early in the technology development so that we make the technologies more greener.
If you like the video, do like, comment, share and subscribe.